general organic chemistry. So this part is actually the most important part of your organic chemistry, right? The concepts which you learn here will be used. I keep saying that these concepts will be used in all the chapters of organic chemistry, right? So that's why it is important. Yes. Okay, so we'll start directly with main points in this chapter. First is the main elements which you will see in organic chemistry. So main elements, so there are many elements, but only the elements which is important from the point of view of organic chemistry that we'll see here. So if you see the the periodic table, you will see hydrogen here, then helium, lithium, beryllium, and on. Then you will have carbon, nitrogen, oxygen, fluorine, then neon, and below nitrogen there will be phosphorus, below oxygen there is sulfur, and this fluorine, bromine, and iodine. This is your halogens. So these are the elements mostly which you will see in organic chemistry. The compounds which you will see mostly will have only these elements. You won't see anything actually. In fact, you won't see anything in your 11th, 12th standard. You won't see anything other than these elements. Now, these compounds and these elements, apart from the elements, you should also note their outermost shell, that is the valence shell. So hydrogen has just one electron in its outermost shell. Carbon has 4. Nitrogen has 3. And mostly it will be in this situation: 1 lone pair and 3 bond pairs. And same thing will be there with phosphorus as well. Oxygen will have 2 lone pairs and 2 bond pairs. Fluorine will have 3 lone pairs and a bond pair, right? And same. So this is the configuration of the outermost shell for all the halogens, right? They will have same configuration, right? So these are the elements, and whenever we say elements, just knowing the name of elements is not sufficient. We should know, or we should be having this picture clear. That is, the summary of this is what? That carbon will have always have 4 bonds in total, right? This will always have 4 bonds. It can be 2 double bonds, so even that is a 4 bond. It can have a triple bond and a single bond, even that is in total, even that is 4 bonds. Next, you will see nitrogen, and nitrogen will have a lone pair and 3 bond pair. Oxygen will have 2 lone pair and 2 bond pair, and halogens will have
1 bond pair and 3 lone pair
and a bonded electron, right? So these are the elements. Now, between the elements, the next thing is obviously the bonds. So what all bonds in organic chemistry you are going to see? Let's see that. So bonds which you will see is a single bond between 2 elements, or there may be a double bond, or there may be a triple bond. So in a single bond, 4 bonds are also possible, but our syllabus is limited to 3, maximum 3 bonds. Now, the single bond which you are seeing, that is always a sigma bond. Double bond means there is 1 sigma plus 1 pi. And triple bond means there is 1 sigma plus
2 pi.
bonds, right? So whenever bonds are formed, so first bond, now this is something which you must have studied in chemical bonding, that first will be always sigma bond, right? First bond is always sigma bond. It can never be that there is a pi bond without a sigma bond,
Sigma bond.
right? So no pi
Can you
bond.
hear my voice?
Yes.
Is it loud enough or is it very feeble?
Yeah, it is enough.
Okay.
So there is no pi bond without an existing sigma bond. This is the basic of chemical bonding which you must have studied, right? So
Yes.
based on this knowledge of bonds which we have seen, right? So then next is what? Whenever you will see carbon and hydrogen, that will be always a single bond, right? And even carbon and halogen. So these will always have single bond, and single bond means always a sigma bond. Then where will you find double bonds? Double bonds you will find in carbon, oxygen,
Oxygen.
right? So in carbon and
Nitrogen.
oxygen, there will be, yeah, in nitrogen as well, but maximum double bond. You won't find a triple bond in carbon and oxygen, right? So carbon and oxygen can also form a single bond, but maximum they will have a double bond. Carbon, oxygen, and something else. So single bond is also possible. Because oxygen can form at the max 2 bonds. So with carbon, the maximum number of bonds one oxygen atom can form is this double bond. It cannot be a triple bond. Now, where will you find triple bond? So carbon, triple bond, nitrogen. Nothing else. I mean, phosphorus obviously just below nitrogen there is phosphorus, so phosphorus can also form. So if you have, where will you find triple bond with carbon? So that will be only
Cyanide.
nitrogen. Yes.
Yeah.
Maximum there will be a triple
Triple
bond.
bond.
Again, this doesn't mean that nitrogen will always form a triple bond. No, nitrogen
Yeah,
can
forms double
form
bond also.
a bond as well.
Yeah, and single bond.
Right? It can form single bonds as well. It can form double bonds as well. But maximum, it can form only a triple bond.
So when it's forming a quaternary salt in ammonolysis, is it 4 bonds or is it still 3 there?
It is 3.
Okay.
Okay. We will come to those specific reactions as well. But right now we are just focusing on these concepts first. Okay. So we have seen elements, we have seen bonds. Now, how are we going to represent
Bond-like structure and
yes, so representation of organic molecules. Now, this is not only limited to organic molecules, but this is mostly used in organic molecules, right? So first, I'll just write it down. I won't give you detail of that because this you must have studied in chemical bonding. So Lewis or Lewis representation. So this is also called dot
structure.
So we actually use dot and cross, right?
Yes.
Dot and cross to represent electrons. So if there is a bond between A and B, say A's electron is here and B's electron is here. So these two are forming bonds. and there may be other electrons if there are any other electrons. So you show them by dots of electron, or you show only dots. So like that, we have dot and cross representation or Lewis representation. So this means there is a bond between A and B, and that is a single bond. If there is a double bond, then say for example, if you have to show a double bond between A and B, then you will be using two dots like this. So that means there is a double bond between A and B. So that is Lewis representation. Next is dash representation or line representation. Actually, here is the example of dash representation. This is Lewis structure. This is dash or line structure or line representation, not structure. Right? Any doubt? Okay. So third form. Now these are just something which you should know. If you have any doubt, we can see this. You can ask me. I hope you don't have any doubt in this. That's why I'm going through this quickly so that we can cover more complex topics in detail. Okay, next form is condensed form. Okay, so from here it is important. Few things we know about the elements and the bonds they will form. So we are going to use the same thing or the knowledge of that in order to just 1 minute, I think. Are you still able to hear my voice?
You're pretty much audible, sir.
Okay, but I think my screen has freezed. Just 1 minute.